Array decay sounds like your array got a virus. In reality, it's when you pass an array to a function, and that function has no idea about the memory allocated for that array. That means your array decayed to a pointer. Anything good always starts with a C file. Call array decay. Might want to open that with a vim. We're probably going to output to standard out, so we're going to need std, standard did point output. We're going to have a main function. All right, let's start by getting the size or length of an array. Yes, I'm going to go ahead and declare the size, but bear with me. We're going to figure out how to calculate that. All right, how we get the length or the size is by using the size of operator. The size of operator returns the size of bytes of the variable. So if we do that, it's going to get the size of bytes for this array, which is basically a size of an int times the number of elements, in this case 5. And to get that, we divide it by size of that array from the 0th or the first element. So this works by taking the entire block of memory from our array and then divide it by the first. And that will give us the number of elements. So let's go ahead and see that. All right, before I compile, you should know that I'm using this const expression here, which is C23. And this is an array initializer, so everything's going to be 0. So I'm going to need standard equals C23. There we go. We knew it was going to be 5. All right, for those of you who don't understand how an array is laid out, let's do it really quickly. Our array we declared with 5, and we set them all equal to 0. So what happens is when we run the program, it asks the operating system, hey, I need an array of 5 integers. Operating system says, hey, awesome, here you go. Here's a memory location where you can put all your integers in. So we get an array with 5. Let's see if I can do this right. 1, 2, 3, 4, 5. All right. Each of those we initialize with 0. So each of these is the size of 1 integer. So our array is basically the size of an integer times the number of elements, which is 5. And to get the reverse of that, if you don't know the size, you divide the full number of bytes, which is the entire array, divided by one of the elements, which we just by convention take the first one. Okay, that's great and awesome. You might be thinking, hey, let's abstract that away into a function. Great idea. All right, since we can just pass the array there, let's do return the size of the array divided by the first element, and that would give us the number of elements in the array. Let's go ahead and comment that out, and since I called it len, I won't be able to use that again. So let's just go ahead and pass our array to that function and recompile and rerun. I want to point out this warning here. Size of on an array function parameter will return the size of an int pointer. Also, we only got 2, which is weird because we know it's 5. So back in our code here, it is warning us that this array variable here is an int pointer. Size of is returning the size of an integer pointer and not the whole part of the memory that our array is using. Let's go ahead and debug with our handy printf function here. So we're going to get size of the array when you put this in parentheses here. And let's see what the size of an int pointer looks like. I'm going to go ahead and call it like this, otherwise it's going to complain. And let's recompile and rerun. When we get the size of an array is 20, which makes sense. And the size of an integer pointer is 8 on this system, which is a 64-bit system. And the reason it's 8 is because it needs to hold enough for an address space on my system, which is 64 bits. And on a 32-bit system, that will probably be 4. Let's go back in there and see what this looks like inside of our function. Going to comment those out. We don't need size of an integer pointer in here because that won't change. Recompile and rerun. Once again, we get 8. So we actually only have an address here. Nothing more than a pointer. When we pass an array to a function, it is changed to nothing more than this, a pointer. Recall our warning. Even though we are declaring our parameter as an array, it is letting us know it has decayed to a pointer, a variable that's just holding an address. But in our function here, the scope of how much space it is taking up in memory is gone. The function has no idea. And that's why we are not getting the correct length of our array in the function. Let's go ahead and fix our function so at least it's not giving us a warning anymore. Now, if we recompile and rerun, we don't get a warning now. And that's because we changed the parameter to a pointer. So if you want to use arrays and functions, you need to have the size as another parameter. So let's just print our array. So we'll have our array pointer, and you need to pass how many elements. This way we actually know how many are in the array. We pass our array, it's a pointer, and we pass how big our array is. If we can recompile and run it again, it doesn't run out of bounds or give us any errors or warnings because we told the function how much in the memory the array is taking up. It starts at the actual address, and then it moves by one integer size and gives us all 5 elements. Awesome. Way to level up by doing. The code will be hosted on GitLab. The link will be in the description. And thanks for watching. Be sure to subscribe, like, share, and comment to defeat that algo monster.